Today, we've got a story for you that honestly sounds like a riddle. It's about a machine with eyes so advanced they're practically superhuman. And yet, at the one moment that mattered most, it was completely and utterly blind. So, let's set the scene. We're starting with this machine, a brand new, multi-million-dollar locomotive. And I mean, this is not your grandfather's train. This thing is the absolute peak of modern engineering, a real glimpse into the future of how we're going to get around. And a huge part of that future is, of course, safety. So this locomotive was packed with a state-of-the-art system specifically designed to stop accidents before they happen. It was built to see everything, to be this perfect, infallible set of eyes on the tracks. But then, during a really important test, the one thing that should never happen, happened. This system, this technological marvel, completely failed to notice a person standing right in its path. It didn't slow down. It just saw nothing. And that right there is the big question, isn't it? How could a machine with senses that are far beyond human capability be so blind to the single most important thing it needed to see? Well, the answer tells us something really fundamental about the AI we're building all around us. Okay, so let's start with what actually went down. This was supposed to be just a routine test, the kind of thing you do to check the boxes and prove how reliable your system is. But instead, it uncovered an absolutely terrifying flaw. The setup itself was pretty simple. The whole point was to see if the train's fancy automated safety system, which uses these super sophisticated LiDAR sensors, would spot an obstacle and hit the brakes. And they had two obstacles lined up. First, a car parked right on the tracks, and second, a person just standing there. And the results were just bizarre. When it came to the car, the system was flawless. It saw the car, it knew it was an obstacle, and bam, the brakes engaged. Perfect. But the person? Nothing. It was like the person was a ghost. To the machine, there was nobody there. So to get why this happened, we really have to understand how this machine sees the world. Because, and this is key, it's nothing like how you and I see things. The technology behind it all is called LiDAR. It's a bit of a mouthful. It stands for Light Detection and Ranging. But the basic idea is kind of like radar. Only instead of using radio waves to map what's around it, it uses tiny, invisible pulses of laser light. It's really a simple three-step dance. First, the LiDAR unit just fires out thousands of these laser pulses every single second. Then, step two, it measures with incredible precision how long it takes for each one of those pulses to hit something and bounce back. And finally, step three, it plots all of those little return signals as individual dots in a 3D space. And what you get at the end of all this, well, it isn't a picture, it's not a video. It's this incredible, detailed digital map made up of millions and millions of tiny dots. And it's called a point cloud. For the machine, this point cloud is reality. Probably the best analogy I've heard for this is to think of it like a form of digital braille. The machine isn't really seeing a car in the way we do. It's more like it's feeling the shape of a car by figuring out the location and the density of all these points. And now we can finally get to the bottom of why this machine was so blind. Because the problem wasn't a broken sensor or anything wrong with the hardware. No, the problem was in the logic itself. Just take a look at this comparison. A big, wide object like a car reflects thousands of those laser points back to the sensor. So in the point cloud, it creates this dense, solid shape that's easy to identify. But a person, especially when you're looking at them from the front, they're really narrow. They reflect very, very few laser points back, creating a pattern that's sparse, kind of scattered, and honestly, it doesn't look like much of anything.
Okay, now here is the absolute crucial piece of the puzzle. The engineers had programmed the system with one really important rule, to prevent it from constantly hitting the brakes for no reason. It had to filter out random, meaningless data, what the system called noise.
So, what did the system think was noise? Well, things you'd expect, right? Like raindrops or snowflakes, maybe a cloud of dust that gets kicked up by the wind. And then, a human being. Because the data signature was just too weak, too sparse. It didn't register as a solid object.
Let that sink in for a second. To the pure, cold logic of this computer program, the handful of data points bouncing off a person on the tracks looked, statistically speaking, exactly the same as a little puff of dust. And so, because it was just following its rules perfectly, the system did what it was told. It ignored it.
And this is why this whole incident wasn't just some random bug. It actually reveals this massive challenge that sits right at the heart of automation. And that's the difference between just measuring the world and actually seeing it.
The sensor did its job perfectly. I mean, it measured all the points. The real problem was the model of the world that was programmed into the machine's brain. The software's idea of reality was just plain wrong. You can see that flawed model right here. The system's entire world was binary. It could only think in two categories: big, dense objects, which meant stop, and sparse, random data, which meant ignore. There was no in-between. No category for small, maybe sparse, but incredibly important. This really gets to the core of it, doesn't it? The locomotive was an expert at measuring. It could collect millions of hyper-accurate data points every second, but it couldn't see. Seeing, well, that requires context. It requires judgment. It's about understanding that some sparse collections of points, like a person, are infinitely more important than others. And look, this isn't just a story about trains. This exact same problem applies to literally every autonomous system we're building. We're talking about self-driving cars, trying to figure out a busy street, delivery drones, you name it. They all have to interpret messy, real-world data, and they have to get it right.
So it really leaves us with this one massive question we have to think about. As we race to build this automated future, are we just focused on giving our machines better and better sensors to measure everything, or are we actually teaching them how to see? Because as this whole story shows, there is a world of difference between the two.